Hello, I'm here today to help you solve the following problem. The problem asks to find the equation of the plane passing through 1, -1, and 1, and contains the line of intersection of the planes x plus y minus z is equal to 2, and 2x minus y plus 3z is equal to 1. So let's write out what we're given, which would be x plus y minus z is equal to 2, and 2x minus y plus 3z equivalent to 1. So to solve for this problem, we're going to want to find a point of intersection. To do this, we're going to set one of these variables equal to 0. So I'm going to set z equal to 0, and we're going to solve for x. So here we have x plus y is equal to 2, or x is equal to 2 minus y. Now we're going to plug in this x into this equation, and we're going to solve for y, keeping z as 0. So here we have 2 minus y is equal to 1. Distribute, we get 4 minus 2y minus y is equal to 1. So that's negative 3y. Okay, so this is negative 3y. We're gonna add it to the other side, and we're gonna subtract 1 over. So we're gonna end up with 3 is equal to 3y, right? Because 4 minus 1 is 3, and we're adding this over. Solving for y, we get 1 is equal to y. And plugging in back here, we get x plus 1 is equal to 2. So we know that x is also equal to 1 when z is 0. So this is a point of intersection. So let's write it out before we erase it. 1, 1, 0. This is equal to the point of intersection. Keep that in mind. I'm gonna make some room here so we can continue the problem and have room to actually solve for it. Okay. So with this point of intersection, we are going to subtract it from this original point. We know it's gonna pass through. So we're gonna have 1 minus 1, 1 minus 1, 1, 0. Okay. Now this is gonna give us, so 1 minus 1, 0, negative 1 minus 1, negative 2, and 1 minus 0, just 1. Okay, so this is the distance between this point and this point. Okay, now we're gonna utilize these two equations again, but instead of having them be in variable form, we're gonna take x, y, and z, 2x, negative y, and 3z as numbers. We're gonna make them numbers. So the first one would be x is positive 1, y is positive 1, and z is negative 1. And for the second, we have x is positive 2, y is negative 1, and z is positive 3. So these are, now what we're gonna do with these is we're gonna cross them. We're gonna cross product these values to find a vector that passes through both planes. So crossing them, we get I. So we cover up the I, and is equal to 1 times 3, 3, minus negative 1 times negative 1, positive 1. So that'll be 3 minus 1, which is 2. minus j, curve up to j, we get 1 times 3, 3, minus negative 1 times 2, negative 2, so 3 minus 2, or 3 minus a negative 2, I should say, that's a positive 5. And now we got plus k, which is 1 times negative 1, minus 1 times 2, 2. So negative 1 minus 2. That'll give us a negative 3. Okay. So now this is the, well, let me write that out. We'll call this our n3, and this will be a vector that crosses through both planes. And we found a point that goes through both planes as well. So now we are going to cross these two. So we are going to get 2, negative 5, and negative 3. I'm going to cross it with 0, negative 2, and 1. Fortunately, I left a little room here to work with, so I'm just going to work on it from the bottom here, if you don't mind. So we're going to cross the I, that'll be negative 5 times 1, negative 5, minus negative 3 times negative 2, so that'd be 6. So negative 5 minus 6, or plus 6, I should say, negative 5. Okay, let me write it out. Minus 6 minus j, so we curve up to j, we have 2, minus 0, plus k, curve up to k, we have negative 4 minus 0. Okay, so from here we get negative 11i minus 2j minus 4k. Okay, now we want to plug this back into the general equation to find an equation of the plane. So this will be r minus r naught dot n vector is equal to 0. Okay, so this general equation can also be written as a x minus x naught plus b y minus y naught plus z, my bad, plus c z minus z naught. Got a little ahead of myself there. This will equal 0. So our x, y, and z naught components, they are going to come from the point of intersection, which, if you recall, was, I'm going to write it down here. Point of intersection is equal to 1, 1, 0. Okay, so let's make more room, because I think you should all have this by now. So let's start erasing. Okay, so let us work up here using the information we have down here. Okay, so we have our normal vector, it should be negative 11, 2, negative 2, and negative 4. Okay, and we are doing the dot of x minus 1, right? Point of intersection, so it'd be x minus 1, comma, y minus 1, comma, z minus 0. Okay, so we can rewrite this as negative 11 of x minus 1 minus in this case plus, because that's a negative 2 plus 2, y minus 1. Same thing applies here, so plus 4 of z, okay. All equal to 0. Okay. And now from this we get, we can distribute, right? So we'll have negative 11x plus 11 plus 2y minus 2 plus 4z is equal to 0. So 11 minus 2 is 9. Subtract it over. We're going to get 11x plus 2y plus 4z is equal to negative 9. And this would be your equation of the plane that passes through point 1, negative 1, 1, and intersects the planes x plus y minus z is equal to 2, and 2x minus y plus 3z is equal to 1. Thank you.